Dear friends, dear colleague, after a short break, welcome back to the Mangano Digital Academy, welcome back to the Essential of Digital Dentistry. In these last 10 videos, we'll focus on clinical application. Let's go back a little bit on the topic, digital dentistry. We have seen through this a long trip together that digital dentistry is based essentially on 4 steps. The first step is the scan phase, data acquisition from the real which goes to the virtual, thanks to beam computed tomography, intraoral phase scanner and digital condylography. Then we have collected a whole set of data we need to elaborate, and we elaborate this data through software, and we make our plan. After that, we need to transform this plan into something real. So we go from the virtual to the real for the making phase or the shaping phase. So we talk about production with milling unit, when we shape with 3D printer, when we make, and with SLS, SLM technology, when we work with metals. And then finally we have our clinical application. This workflow, this path is valid for the prosthodontics, for the surgery, and also for the orthodontics. And we have seen several cases, several applications already, but now we'll see in these 10 last videos more clinical cases. And let's talk a little bit about the full digital workflow as I work with in my little clinic on the Lake of Como. This is an example. We start with a beam computed tomography. In this case, we need to replace the lost 37, as we can see here, and there's a huge defect after the extraction. And then we also have to replace the number 36, the first molar on left mandibular first molar, because it's broken and it's not restorable. So we start from a beam computed tomography, in this case the CS9600, and in the software we make a fast pre-evaluation of the quality of the available bone, the bone volume, and also the thickness of the bone crest and the height of the bone crest for an implant placement. After that, we go straight to the intraoral scan, because the intraoral scan is essential. With CS3800 we capture the master model where the implant should be placed, of course, but also the antagonist in the occlusion and the bite, because we need to prepare obviously a virtual waxing, and the virtual waxing is prepared into exocad, and then it is imported in the implant planning software. In this case, we are working with the materialized software Mimics, and here we place our implant together with the scan body, because it can be helpful in the case we would like to proceed with an immediate loading. In this case, this is not the case because we are in the posterior area, but anyway, we can place our implant, we can plan our implant in position, in depth, in inclination, according to the residual bone volume and according obviously to the emergent profile, the ideal emergent profile given by the waxing. And as you can see here, we can evaluate everything in the cross section. In this case it's not so easy because we have an area to regenerate, but with the guided surgery system we'll use here, the HypnoGuide, it is possible to work open flap quite easily and also to regenerate bones, so during the implant procedure. So this is how it should look like, the planning. And here is the surgical guide design, because we are free to export the position of the implant, the position of the model, the position of the scan bodies as well, into a third-party software. In this case is Mesh Mixer by Autodesk, and here we can design our surgical guide. It is an HypnoGuide. HypnoGuide is a thin metal guide conceived for the partially edentulous patient, exactly for this application, and it is a guide that can be tooth supported, or in some cases tooth supported and bone supported as well, thanks to the application of the artificial intelligence using software, for example, like Relu or Dianiocat. Is it possible also to obtain a bone segmentation that is automatic and use this bone segmentation for making, in this case, through a Boolean operation, a surgical guide that is not only tooth supported but also bone supported. In this case we opted for a tooth supported because we have a distal tooth supporting our guide, but in the absence of a posterior support it may be feasible to have the cylinder posed to the bone through a Boolean operation. That is not the case, but as you can see, we can design the guide, and this is basically the design of the surgical guide, as you can see here. So from the top and from the bottom, these surgical guides are produced like in 3 or 4 identical copies, and inside we can place a sort of a sleeve that is milled in polyether ether ketone, and the sleeve is absolutely conceived for the use of that specific drill, and you don't need to use during the surgery any stop for the drill. You don't need to use during the surgery any reducer for diameter, because all the guides are conceived exactly for that case and for the use of standard length drills of the standard kit, in this case of the AnyRidge Megagen implants, the implant we use in this case. So this is how the surgery goes. It's quite, I mean, fast and easy, because we can make the anesthesia, raise a mucoperiosteal flap, then we place the first guide and we drill, we remove the first guide, we place the second, we drill, we remove the second guide, we place the third, and we use our drills. Every single guide is for the use with one specific drill, and in this case we had like 3 guides because we wanted to place 2 4.0 implants in this patient, and it is what we did. Basically, the implant when placed manually, so we are talking about a guided surgery, but it is a computer assisted technology. And then we can make the regeneration, as you can see, with particle of hydroxyapatite and beta-tricalcium phosphate, entirely synthetic, and then our suture. It's a minor bone regeneration, and it's everything. It's very easy to perform around this AnyRidge implant. The stability is excellent. And then we go to the prosthetic phase after 1-2 months, depending by the situation, by the consistency of the bone and everything. In this case, after 2 months, we took another scan, in this case with the master model with the mucosal collar after the removal of the healing abutment, and of course the antagonist and the bite. And then we placed obviously the scan body from the Megagen company, and we captured this scan. And after this, we can easily send all this file in polygon file format, PLA, or in STL, standard tessellation language format. We can send this file to the dental technician. The dental technician can use Exocad to prepare individual hybrid abutment, to model individual hybrid abutment and the definitive crown. And it's quite easy. The definitive crown are monolithic restoration. In this case, in zirconia, it's a bridge in this case. And as you can see with the photorealistic rendering, the technician can care about everything, basically the support, the emergent profile on the individual hybrid abutment. Individual hybrid abutment is an abutment in zirconia that is milled and then cemented extraorally on a titanium base, selected for the case. And here it's the delivery of the individual hybrid abutment, because we love the cemented way. We love to cement our restoration over this individual hybrid abutment. And these are the final restoration at the delivery, as you can see here. And basically this is the outlook of our restoration, our monolithic zirconia bridge, perfectly integrated into the mouth. And 1 year after, the control revealed a perfect integration and the stability of the soft tissues, even in the area of this minor bone regeneration. So this is the radiograph at the moment of the implant placement, and this is the radiograph 1 year after the delivery of the final restoration, in this case this bridge. And as you can see, there's a stability of the bone and a very good healing, and the function is respected, the biology is there, and also the aesthetic for the patient. So thank you very much for your kind attention.